All right, 20-1s. Let's follow up the sine law with the cosine law. Again, sine law, we talked about the fact that we don't have right angle triangles. We have non-right triangles, and we want to find angles or we want to find side lengths. What was important with the sine law? That if I wanted to use the sine law, I had to know an angle and the side opposite it for the sine law to work. You had to have an angle-side pairing. You had to know angle A and side A, or angle B and side B, whatever it was. That angle-side pairing was essential. You're not always going to have that. In which case, we have the cosine law. And the cosine law is not a big step in a bunch of information. It's recognizing the cosine law has to be used and understanding that we're looking at two different formula to use. So the cosine law, if you can't use the sine law, has that formula or that formula to work with, which will always be given on a formula sheet to you. Take note that the first formula basically would be used to calculate a side length, lowercase a, if that's the side you're trying to find. Well, and the fact that it's a squared, eventually you're going to have a squared equal to some bit of information. Note that every time you're finding a side length, the last step will always be square root to get a by itself. The second formula is to calculate an angle. Capital variable means an angle. So you would plug in a bunch of side information to find the angle. But again, one quick note, that if you punch in a whole bunch of information, this calculation here is going to be not your answer because it would be cosine A. Remember, anytime you're going to find an angle, it's second function inverse cosine, whatever it is. So that's all it is. Two different formulas that we need to utilize and utilize effectively. So let's take a look at this first example. Why are we going to the cosine law? Well, in this case, we have an angle and we have two sides. With one angle, I can't find the other two sides using 180 rule, so I only have that angle. I have two sides. I can't find DF. Again, some of you are thinking, why not Pythagoras? Because it's not a right triangle. That's why we're using the cosine law. So there's no angle-side pairing. I have an angle, but no side opposite. I have a side, but not the angle opposite. I have another side, but not the angle opposite. So the sine law doesn't work. So now we go to the cosine law. Now, a couple things with the cosine law. This particular question, it's asking us to find side E. Well, we have two formulas that we just talked about. We're going to use the first formula because that's the formula that calculates side length. Now, two things to do though. The hardest part sometimes is when it's labeled something and our formula though is based on using triangle ABC. Well, you should be able to switch up the variables. This formula solves for A. We're trying to find E, so we would want the formula that's solving for E squared. But we have to make sure. We have to have the right stuff in the right place. If I'm going to use A squared, where else is it important? Well, cosine A would have to be cosine E. It's essential that I'm consistent with which variable's which. So we would have E squared equals, and I'd have to finish eventually by having cosine of angle E, because those pair up. The other variables in here, B and C, B squared plus C squared, they're interchangeable. 2B times C, B and C are interchangeable, so that's nice. So that means the other two sides, which in this case would be side F and side D, they're interchangeable. D squared plus F squared subtract 2DF times cosine E. Note that this is 2 times B times C times cosine of A, or in this case, cosine E. So that's one possibility. Just making sure that you have a formula where you're plugging in the right information. Whatever side, that's the angle that has to be part of the question. So the other possibility, and I have been mocked by people that are higher level mathematicians. For me, I say, you want to know something? If I want to find side E, well, I'm going to call it side A. So I'm just going to change the labeling. Angle A defines side A, because that's the side we're trying to find. It's asking for E, well, that's the one. And if that's A and A, then that means these other two sides or angles just have to be B and C. So that would be side B, that would be side C. Now I can plug into the formula. You can change the labeling on the triangle, or you can change the labeling in the formula. Geeky math people like myself, you should really be able to change the formula. E squared is D squared plus F squared minus 2dF times cosine of E. So substitute into that. Quick labeling, if there's E, we're trying to find E. Opposite angle F is side F, opposite angle D is side D. And we just need to plug in. 5 squared plus 3 squared minus 2 times 5 times 3 times cosine of our 74 degrees. That's what E squared will equal. Now, as we've talked about in other units this year, this is not difficult, but plugging into your calculator, it's up to you if you do it all at once. I personally would probably plug it in order of ops, just to make sure, but you could substitute all of it in at once in your calculator, but putting in brackets to make sure certain things do happen first wouldn't be horrible. Make sure you can get the right value with your calculator. Breaking it into steps wouldn't be a bad thing either. There's nothing wrong with, well, E squared is equal to 5 squared is 25, 3 squared is 9, 2 times 5 times 3 times cosine 74, 8.269. 3 decimal places is acceptable. At that point, E squared is equal to 25 7/10. However, we want E to be by itself. Make sure you square root. And E has a length is 5 1/10. I mean, the cosine law is that easy. It's the labeling that can really cause grief at times. Let's take a look at example 2. It's not labeled. Information is given in the question. Labeling doesn't hurt. We want to find angle C to the nearest degree. A is 12, which means opposite is angle A. B is 18, so that has to be B. Opposite is angle B. And 15 is C, so opposite it would be angle C. Everything's labeled nice. We're trying to find angle C. Now again, trying to find an angle, we're going to the second formula. But I can't use the variables as it is, because this, if I plug in B squared plus C squared minus A squared over 2 times B times C, that's going to work for angle A. We're not trying to find angle A in this question. We're trying to find angle C. So again, we have to be careful with the labeling. We want the cosine of C, because that's what we're trying to find. So that means this angle A and A have to be consistent. I can't have C here anymore because I'm trying to find C. So I have to make sure my B squared hasn't changed. But C squared finding A means that has to be A squared if I'm finding C. You have to manipulate your formula to suit what you're looking for. The other possibility here is 2 times B times C. Well, that can't be C anymore because we're finding C. It would actually be 2BA. So manipulate the formula to suit what you're looking for. The other possibility, like I said, would, if you prefer, change your labeling. If you're trying to find angle C, well, I'm going to call it A because that's what my formula finds. So that would be side A. B is still okay, but I can't have angle A anymore. I need that to be C, so this is going to be C. So I could relabel my triangle. Either way is going to get you the right answer, but you have to make sure you're using the right values. So again, very quickly, I'm just going to use my new formula with the variable switched up. A is 12, there's A, 15 is C, so there's C, there's B, and there's B. So now I substitute in. Cosine of C is B squared, 18 squared, plus A squared, which is 12 squared, minus C squared, which is 15 squared, over 2 times 18 times 12. Cosine C, again, lots to plug in the calculator. It wouldn't hurt. If you prefer, get a value in the numerator, do the value in the denominator, and divide them. Whatever it works, but you need to make sure you know what to substitute in. Cosine C is decimal 5625. So when we're finding the angle, we need to inverse or second function to get angle C, which is 56 degrees. Easy formulas to work with. You should have that ability. It's the labeling that can cause you grief. Solve the following triangle. Anytime a question says to solve the following triangle, that means you need to get all the unknown information. So we have to, at the end of it, know what P is, know what angle R is, and know what side Q is. All that information needs to be solved for. We now have sine law and cosine law, so we have both to work with. Pythagoras won't work because it's not a 90 degree, but the 180 would work. If I can find one more angle, I can use 180 to find the other angle. So, all kinds of possibilities. We can't find the angle yet because the angle requires that we know all three sides, which we don't know. So I have to start by solving for Q. So Q squared, changing my formula, will be side P squared plus R squared minus 2PR times cosine of Q, which I do know. Substitute into that. Q squared, 16.4 squared plus 13.8 squared minus 2 times 16.4 times 13.8 times cosine 58 degrees. Lots, big long formula there. So when I substitute all that in, if you effectively, and you should practice this, make sure on your calculator we should end up with Q squared equal to 219.5373, but we always square root to get Q, and Q works out to be 14 8/10. So we know that that's a 14 8/10 calculation. Well, once we know that, now I have three sides, so now I can calculate angle P or R because I know the three sides. Which one? It doesn't really matter. I'm going to do angle P and change your formula. Cosine of P will equal Q squared plus R squared minus the P squared. Whatever angle, I need to subtract that side length squared times 2QR. So when I plug in, cosine of P should be Q is now a calculated value, which is never always perfect to use a calculated value to find something else, but we have to, plus 13.8 squared minus 16.4 squared all over 2 times 14.8 times 13.8. Effectively use your calculator, and if you do, your cosine p-value, all of this right side fraction should work out to be 0.3448, and then we inverse cosine to get angle P equal to, it says to the nearest tenth. I'm going to go nearest whole degree because that's usually what angles are. You should have a 70-degree angle. We have not quite finished solving for the entire triangle because we still need R. I could use sine law now. I could, because I have an angle side pairing. I could use cosine again, but I'm going to trust what I have, and it's okay as long as you show how that angle R will equal 180 minus 70 minus 58, and angle R works out to be 52 degrees. So there you go. At that point, we solved for all the parts of the triangle. The only drawback here, show what you've done. I can give you a part mark if you've made a bonehead on the 58 and you use the wrong thing to find something, but at least you're showing me you understand what you're doing. The great thing about the cosine law is that there's no ambiguous, goofy situations like sine law. The cosine law is the cosine law. It is what it is. There's your assignment. Textbook, page 119, worksheet A, couple different sections, cosine law. Give it a try.